Good morning, students. I think yesterday you have solved that problem. It's very simple. The answer is 12 Newton meter. The work done by the force on displacing a body along z axis is 12 Newton meter. 12 joules. Okay. Now let us solve one more problem. A cyclist comes to a skidding halt in 10 meter. A cyclist which is in motion, a cycle which is in motion, the cyclist comes to a skidding stop in 10 meter. During this process, the force on the cycle due to the road is 200 Newton meter. The force on the cycle due to the road is 200 Newton and is directly opposed to the motion. Force on the cycle tire due to the road is nothing but frictional force and it is directly opposing the motion. So the force of friction is 200 Newton. That's how you have to understand. Next, how much work does the road do on the cyclist? What is the work done by the road in stopping the cycle? That is first. Second, what is the work done by the cycle on the road? How much work does the cycle do on the road? These are the two simple problems. Now, as I said, the force on the cycle due to the road, the stopping force on the cycle is frictional force due to the road surface is Fk, kinetic friction, 200 Newton, and the displacement is 10 meter. Stopping distance or you can say displacement 10 meter. Therefore, work done by the stopping force or work done by the road on the cyclist becomes equal to Fk into d. So, since both are vectors, so you have to take Fk dot d, Fk vector dot d, where Fk is kinetic friction. So, this value, both values are given, dot d is nothing but Fkd cos theta. So, what is the angle between the kinetic friction and the displacement? Kinetic friction is always opposing the motion. Therefore, kinetic friction is in the opposite direction of displacement. So, the angle between kinetic friction and the displacement is 180 degree. Here, theta between Fk and d is 180 degree. Therefore, if you substitute, it becomes Fkd cos 180. Cos 180 is minus 1. Therefore, it becomes work done by the road on the cyclist becomes minus Fkd. So, just substitute the values, minus 200 into displacement 10 meter, 200 into 10 meter. So, that becomes minus 2000 Newton meter. So, minus 2000 Newton meter is work done by the road on the cyclist. work done, how much does the cycle do on the road? How much work does the cycle do on the road? By Newton's third law, for every action there is an equal and opposite reaction. If the road exerts an opposing force of 200 Newton on the cycle tire, the cycle also exerts same force on the road. So here it is going to be 200 Newton on the road. But the cycle undergoes displacement. The road does not undergo any displacement. Therefore, work done by the cycle on the road, work done by the cycle on the road becomes zero. But Newton's third law is about the forces, not about the work done. So we'll conclude it. Second part, B. Force by the road on the cycle is equal and opposite to force on the road by the cycle. So that's equal to minus 200 Newton. Here if you are taking minus 200 Newton, here it will become plus 200 Newton. If you are taking plus 200 here, this will become minus 200. This is according to Newton's third law. According to Newton's third law. For every action there is an equal and opposite reaction. Force on the road by the cycle must be equal and opposite to force by the road on the cycle. Once again, force by the road on the cycle tire must be equal and opposite to force by the cycle on the road. Therefore, it is minus 200. But what about work done? Work done by the cycle. Work done by the cycle on the road is equal to minus 200 into 0. So it becomes 0 since the road does not undergo any displacement. Since the road does not undergo any displacement, therefore displacement is 0. So work done by the cycle on the road becomes 0. So this is a simple problem. So Newton's third law only says about the forces, not about the work done. So work done may not be equal. Work done by the road on the moving cycle will not be equal to work done by the cycle on the road. That is clear from this simple problem. Now let us study one more important equation, and we call it as work energy theorem. Work energy theorem relates the change in kinetic energy of a moving body equal to the net force acting on the body. What does it mean? Let us see. Okay, before we go into the further details, let us discuss about the units of energy, units of work done. As we have discussed earlier, work done and energy are measured with the same units. The SI unit of work done and SI unit of energy is joule. In short, it is written as J. What do you mean by joule? Let us suppose If a force of 1 Newton acts on a body which displaces it through a displacement of 1 meter, then the work done on that body is equal to 1 joule. If an applied force of 1 Newton changes the position of an object through 1 meter displacement, then the work done on the body is 1 joule. That's how we define 1 joule. Suppose this is an object and it is displaced through a length of 1 meter by applying the force of 1 Newton. Then the work done on this body is 1 Newton meter, that is also equal to 1 joule. If an applied force of 1 Newton displaces a body through a distance of 1 meter along the direction of force, then work done on the body is equal to 1 joule. Therefore, 1 joule, in short we write capital J. 1 joule is equal to 1 Newton meter. 1 Newton meter. Then this is the SI unit. What are the other units? Other units of work done on energy. So this is the SI unit. In CGS unit we use the unit called as erg. CGS unit of energy is erg. Remember, 1 erg. So on the similar line, if an applied force of 1 dyne, see here, dyne is the CGS unit of force. If an applied force of 1 dyne changes the position of a body through a displacement of 1 centimeter, then the work done on the body is 1 erg. If this displacement is 1 centimeter and the applied force is 1 dyne, I will just draw a simple diagram. If this is the body and if this is displaced through a displacement of through a distance of 1 meter, not 1 meter, 1 centimeter. When we apply force of 1 dyne, then 1 dyne centimeter is equal to 1 erg. That is the CGS unit of work done or CGS unit of energy. Therefore, I can write 1 erg is equal to 1 dyne centimeter. Then the question comes, what is this dyne? Here, dyne is CGS unit of force. CGS unit of force. You should remember all this. It is very important while there is a conversion of units from one system into another system. Then what is 1 dyne? Here we know what is 1 Newton. Here 1 Newton is equal to 1 kg meter per second square. This is how we defined in the last topic where we learned laws of motion. In the same way, time can be defined. If the mass is 1 gram and undergoes an acceleration of 1 centimeter per second square. If a mass of 1 gram undergoes an acceleration of 1 centimeter per second square, then the force acting on that body is 1 dyne. So I will write here. Here dyne, 1 dyne is equal to 1 dyne is equal to 1 gram centimeter per second square. 1 gram centimeter per second square. This is the easiest unit of force. Right? Now, how to convert joule into erg? This is a very interesting conversion. It is an exercise for you. You can try it. Convert joule into erg. Means how many ergs is equal to 1 joule? How many ergs is equal to 1 joule? Yes, we can do it. Before that, we should know how many dynes is equal to 1 Newton. How many dynes is equal to 1 Newton? So let us do that. Conversion of dynes into Newton first. Then we can go for conversion of joule into erg. I mean, how many dynes is equal to 1 Newton? So that can be obtained from this equation directly. So first we will do conversion of or relation between dyne and Newton. Units of force. We have, first we will write what we know. We know that 1 Newton is equal to 1 kilogram meter per second square. Just substitute what is 1 kg, how many grams? How many grams equal to 1 kg? So this becomes 1000 grams, 10 raised to 3 grams. 10 raised to 3 grams equal to 1 kg. Can write separately. 10 raised to 3 grams. Then 1 meter equal to how many centimeters? 1 meter equal to 100. That is 10 raised to 2 centimeter. Substitute here. So 1 meter equal to 10 raised to 2 centimeter by second square. Therefore, now you can write 10 raised to 3 into 10 raised to 2. 10 raised to 5. Thus, 1 Newton is equal to 10 raised to 5 gram centimeter per second square. What is 1 gram centimeter per second square? Dyne. Therefore, 10 raised to 5 dynes. 10 raised to 5 dynes is equal to 1 Newton. 10 raised to 5 dynes is equal to 1 Newton. In the same way, we can convert how many ergs equal to 1 joule. Relation between ergs and joule. We know that 1 joule is equal to 1 Newton meter. 1 Newton meter. Now 1 Newton is equal to how many dynes we know? 10 raised to 5 dynes. Into meter. 1 meter equal to 100 centimeter. 100 centimeter. Just substitute. Thus we get 10 raised to 7 dyne centimeter. What is 1 dyne centimeter? 1 dyne centimeter equal to 1 erg. Look at this. 1 dyne centimeter equal to 1 erg. Therefore, 10 raised to 7 dyne centimeter implies 1 joule is equal to 10 raised to 7 erg. Remember this. Therefore, 10 raised to 7 erg is equal to 1 joule. So, this is how you should remember the units of energy. SI unit of energy is joule. CGS unit of energy is erg. So, what is the relation between joule and erg? 10 raised to 7 joule is equal to 10 raised to 7 erg is equal to 1 joule. 10 raised to 7 erg is equal to 1 joule. For units of force, Newton is the SI unit of force and dyne is the CGS unit of force. What is the relation between Newton and dyne? 1 Newton is equal to 10 raised to 5 dynes. 1 Newton is equal to 10 raised to 5 dynes. 10 raised to 5 dynes. So these are important conversions which will be helpful while solving your problems. Now other units of energy are also being used. That is 1 electron volt. When we study the nuclear reactions, the energy evolved are always measured in terms of electron volt. So 1 electron volt is equal to charge of an electron multiplied by volt. So that comes out to be 1.6 into 10 raised to minus 19 joule. So 2 more units are there. Let us write those 2 more units. Okay, listen here. This is another commonly used unit when we discuss about the nuclear reactions. Electron volt is equal to 1.6 into 10 to the power of minus 19 joule. What is 1 electron volt? Simple. If an electron is accelerated by a potential difference of 1 volt, then the energy possessed by the electron is 1 electron volt. If an electron is accelerated by applying a potential difference of 1 volt, then energy with which the electron is moving, energy possessed by the electron is 1 electron volt, that is equal to charge of an electron multiplied by 1 volt. 1.6 into 10 to the power of minus 19 joule. So, if you convert charge coulomb and volt, if you just substitute coulomb into joule per coulomb, right? Electron is having a charge 1.6. You can just write it like this: 1.6 into 10 to the power of minus 19 coulomb. This is the electronic charge. And what is 1 volt? You have learned last year, 1 joule per coulomb. So coulomb cancels, and thus you are getting 1 electron volt as equal to 1.6 into 10 raised to minus 19 joule. So this is another unit of energy. One more unit of energy as far as heat energy is concerned, as far as body energies are concerned, food energies are concerned, they are measured in calories. What is 1 calorie? 1 calorie is equal to 4.186 joule, or you can remember it as 4.2 joules. 1 calorie, CAL is the short form of calorie. 1 calorie is equal to 4.2 joules. So this is another unit which we commonly use while measuring the heat or related energies, food energies and all, in terms of calories, food calories, if you remember. And one more very important unit which you have learned last year, unit of electrical energy. commercial unit of electrical energy, that is kilowatt hour. Commercial unit of electric energy. Kilowatt hour. 1 kilowatt hour. You see, 1 kilo means 1000. Watt means joule per second. 1 watt is 1 joule per second, and 1 hour is 60 into 60 seconds. 60 minutes into 60 seconds. So thus it becomes 60 into 60 seconds. You see, second cancels. So when you cancel this second, then 1 kilowatt hour, you see, it becomes 3600 into 10 raised to 3. So thus we can write it as 3.6 into 10 raised to 6 joules is 1 kilowatt hour. This is how we use this as commercial unit of electric energy. These are some other units of energies that we come across while we study this topic. Okay, next one is work energy theorem, that we shall see in the next video. So please practice these conversions. These are very good exercises which will be helpful while solving the numerical problems. Okay, thank you, have a nice day.